So I want to welcome everyone here to the first of our spring 2017 seminars. My name is Nancy Holm, as many of you may know, and I'm Assistant Director at ISTC and Seminar Organizer along with Beth Mashesky. We have the schedule for the spring seminars out on the table outside the conference room here, and also they are listed under the events on our website for those of you who are listening online. And if you cannot attend in person, all of our seminars are shown live via GoToWebinar, and then we also record and archive those on our website, and we have over 120 or 130 of those from the past about 8 years on the website. To begin the seminar, I'd like to ask everyone here in attendance to please silence your cell phones if you haven't done so already. And we'll also hold the questions to the end for the speaker, and I'll come around with the microphone so we can record those and people online can hear those. And then for those online, you can type in your questions at any time, and then we'll answer those at the end also. So we're very pleased today to welcome our speaker, Dr. Mary Turyk, who's Associate Professor of Epidemiology in the School of Public Health at the University of Illinois at Chicago. Her specialty is in environmental epidemiology. Her research focuses on the impacts of environmental pollutants, such as persistent organic pollutants, metals, and phthalates, and on metabolic pathways, including disruption of hormone and glucose homeostasis. Her research on potential biological pathways mediating the association of persistent organic pollutants exposures with diabetes in a cohort of Great Lakes fish consumers suggested that persistent organic pollutants may have a stronger impact on blood glucose in persons at higher risk for diabetes. Methylmercury is also an area of interest for her. In partnership with community-based organizations, Dr. Turyk and her colleagues at UIC are evaluating the health benefits and risks of seafood consumption in Chicago Asian communities with the final objective of tailoring public health text messages to subgroups at risk. So Dr. Turyk will be talking about both of those studies today, as well as some other ongoing work and interests. And so please join me in welcoming Dr. Turyk for her presentation.
Okay, I think I'm on. Thank you. Thanks very much. I'm really excited to be here, and I really appreciate the invitation to present and talk about what I think is really interesting work in environmental public health. So let's see. Okay, so I'm going to start off the talk by let's talk about what's in Great Lakes fish. Why would we want to study fish? And we have to keep in mind when we're talking about contaminants, which we're going to talk a lot here, is that there's a lot of benefits from eating fish. And it's not just the nutrients, but it's also that there are cultural traditions, and there's also recreational benefits of angling. And then we know there's a lot of health benefits. And in particular, the research has focused on maternal consumption of fish and the increases in neurodevelopment in the offspring, and as cardioprotection for decreasing coronary heart mortality in older adults. This is some data that I analyzed in conjunction with the International Joint Commission, and we had Great Lake trout and Great Lake whitefish from several of the Great Lakes. And this is just total EPA and DHA milligrams per 100 grams of fish, and in comparison, fatty marine fish. So this data on fatty marine fish was from the USDA databases. And while it's not quite as high levels, I mean, there's still substantial levels of omega-3 fatty acids in fish. And actually, since this work, the EPA has been doing quite a bit of work looking at omega-3 fatty acids in the same fish that they're monitoring the emerging pollutants. So let's talk about the emerging pollutants and the legacy contaminants. So these are the contaminants I'm going to focus on today. We've done a lot of work with PCBs and DDT, which you probably are all aware is the most persistent metabolite of or DDE we've worked with, which is the most persistent metabolite of DDT. We've worked with PBDEs and PFOS, and we're going to talk about methyl mercury. We actually haven't looked at that in the Great Lakes cohort, unfortunately, but we are looking at it in other studies. So I probably don't have to do too much of an introduction on PCBs for you because I suspect most everyone has a pretty good knowledge of some of the legacy pollutants. One thing I did want to mention though is the toxicologic properties of PCBs. So PCBs are 209 different congeners, and then they're very similar to dioxins and furans, which also have a number of congeners. And the congeners have very different properties. And the one the one measurement that's been very well known in the literature is the toxic equivalence. So the how much dioxin-like activities the chemicals have. But not all PCBs have dioxin-like activities. They have a number of other activities, and they can have estrogenic effects and anti-estrogenic effects. And the effects can be different based on what tissue and what age of person you're looking at. So, so that's one thing to keep in mind. Whoop, I just did that automatically. The other thing is, well, we have a lot of exposure from fish. Other animal products is also a source of exposure. And that's kind of in contrast to mercury, where we get most of our exposure from fish. And then there's also the potential for PCB exposure from the indoor environment, because we know it was used in a lot of products. So, so we can't really use just fish consumption as a metric for PCB exposure. We have to actually measure it because it can be coming from other sources. And I think everyone's probably aware that it has really long some congeners have a very long half-life in the body. Others are very non-persistent, and they could be having health effects, but we really don't know because we don't generally see them when we measure human blood samples. So this is some data from the state of the Great Lakes. The most recent one I could find was 2011. And these are PCB levels in the top predator fish, which is generally lake trout. I think it's walleye in Lake Erie is the top predator. And you can see the general trend for decreasing levels. However, if you look at the axis, the y-axis, you can see there's a big difference for some of the lakes, and that there's actually much higher levels in Lake Ontario and Lake Michigan. And that's really related to the industry in that area. And the EPA's assessment, the State of the Great Lakes assessment was fair status basin-wide and improving levels. But it's also important to note that some of these levels are still high enough to trigger sports fish consumption advisories. DDE, the metabolite of DDT, is something that is also measurable in Great Lakes fish. And we also see associations of DDE levels with years of sports fish consumption in our cohort. I'll talk about that in a little bit. The State of the Great Lakes didn't have additional data, but additional charts. So this is a little older chart, but their basin-wide status is good and improving. So PBDEs are chemicals we began studying in about the I think 2004, 2005, we began measuring those. And at that point, we thought that we would see strong associations with fish consumption in our participants. I'm going to show you what we actually found in a little bit. But we do see that they did increase in Great Lakes fish through about the early 2000s. And then there was a voluntary phase out of the penta-PBDE product, which is what was used the most in foam, and so upholstered chairs and carpeting pads and all kinds of consumer applications. Actually before the phase out, which is interesting, we started to see a decline in levels in the fish, or at least a leveling off of levels. There's also a whole lot more measurements in this time frame, was because people started really getting interested in these chemicals around then. So we think that probably more of our exposure is coming from dust indoors than it is from fish. But this could change as time goes on, and more of the furnishings that are contaminated go into landfills, and the chemicals get more dispersed in the environment. Another chemical that I haven't worked with in the cohort, but that is of great interest to people, I think, is PFOS, the perfluorooctane sulfate. And this is some data from the state of the Great Lakes, and this is a slide from Bernie Crimmins at Clarkson, who he led it to me, and he looked at PFOS in lake trout, and this is in Lake Ontario. And again, you can see a difference between the Great Lakes. You can see, if you notice the scale, the lake trout from Lake Superior is down in this level, and you get much higher levels in Lake Ontario. And finally, mercury, which is probably the chemical most people think of first when they think about fish contaminants. So mercury it's persistent and bioaccumulative, but its half-life is actually much shorter in humans than PCBs and some of the legacy pollutants. So this is data from the state of the Great Lakes. And, and you can see that the decreasing trend that we see with POPs is not really evident here in the Great Lakes for mercury. And also that the levels are fairly similar across all the Great Lakes. We don't see as much of the difference that we do with the POPs. And so this suggests that the contamination in the lakes is atmospherically driven rather than point sources. So none of this is that surprising. But it's good to have. I really think this information from the EPA is really useful. All right, so on to the epidemiology. So the Great Lakes Fish Consumption Study was originally funded by the ATSDR. They funded a lot of projects. I believe there was one down here. Susan Shantz was looking at toxicology of PCBs on hearing, I believe, neurodevelopment and hearing. And hers was, but I was not part of the study at the beginning, but this was a consortium of 5 state health departments, and it was led by Henry Anderson at the Wisconsin Department of Public Health. And so the state public health departments in each of the states actually took responsibility for going out and recruiting participants. So it was a true collaboration. And so they used state charter boat licenses to recruit charter boat captains. And then once they recruited the charter boat captains, then they used random digit dialing to recruit reference who had low Great Lakes sports fish consumption ingestion from similar areas around the lakes. And so most of the population is in Michigan and Ohio, and Wisconsin's the third state, and then there's just a sprinkling of people from Illinois and Indiana. So most of this really focuses on lakes Michigan, Huron, and Erie. This is just a summary of the timeline, and the things that I wanted to point out of interest here are there was a large group that was recruited initially and just got a phone survey, and then there was a subgroup of 619 that were recalled, and they collected additional data as well as serum samples to test for PCBs and DDE. And then UIC got involved with using some of the leftover samples to look at hormone levels, and then we looked at associations of hormones, of thyroid and steroid hormone levels with PCBs and DDE. That was published, I think, in 2001. So, and then the ATSDR refunded a health survey and repeat measures to see over like 6 or 7 years how PCB exposures had changed. Then we got some funding from the EPA from a STAR grant, and we were able to do a health survey. We went back to all the original cohort members, and we didn't get all of them, of course, you never do in an epi study, but we got some health outcomes, and then we did hormones and contaminants, this time including the PBDEs, in a subgroup. And then I did, for my diabetes follow-up study, I did a health survey in 2010. And we now have a graduate student who's just getting ready to go out in the field with another follow-up health survey. And I have another doctoral student who has funding from NIOSH to do mortality studies. So we're searching the National Death Index on all these original participants, and we've so far found we have over 700 deaths. So she's going to be looking at the effects of fish consumption and POPs on cardiovascular and other mortality endpoints. I don't think we'll have enough to be able to really tease out cancers. So this is some data from the cohort, and I have this separated by different chemical exposures at the bottom here, so PCBs, DDE, and PBDEs, and then stratified by sex because we see quite different levels in men and women. And then the first bar is our original study in 94-95. This one is 10-year later follow-up. And then for comparison, I put the NHANES data for a similar demographic group for these chemicals in the dark blue bars. So, and this is the sum of PCBs. So you can see DDE levels, just the one chemical, is actually higher levels in some cases than the PCBs. And the sum of, I think it was 11 PBDEs, is relatively small compared to what we see for the legacy pollutants. So we did see, and you can also note that we did see a decline over time, which we think possibly could be related to changes in fish consumption habits, at least in some of the captains who were higher fish consumers. And it may be also related to just the exposures were higher in the past, and now people are metabolizing. So over time, they're losing some of their body burdens. We did publish, one of our papers looked at breastfeeding and pregnancy, and we did see that that was associated with lower levels of PAPs in women who had longer breastfeeding duration or more pregnancy. So we also know that that can be a way where PAPs are, because PAPs are transferred to the fetus. So just to give you an idea of what we found were determinants of PCBs. The top determinant of PCBs was the years of eating sport-caught fish. The more they ate it, the higher it was. Male sex was higher than females. And this really is more related, rather than a gender-specific difference, it's related to the amount of fish. The captains were just eating a lot more fish than their wives were. Oh, that's interesting. Specific types of fish that were related to higher levels were rainbow trout, chinook, and salmon. They increased with age, and the participants who lived near Lake Michigan had higher levels than those who lived near Lake Erie or Lake Huron, which correlates with what I showed you earlier, that the fish from Lake Michigan have higher levels of the PCBs. So overall, we were able to explain 42% of the variation in serum PCBs by these 5 factors. That was published in 1999. For PBDEs, it's very different. Overall, even though we asked a lot of questions about furnishings and indoor and diet, we were only able to explain 7% of the variation in PBDEs. And years consuming sport-caught fish was associated, but obviously it's not really explaining as much as the PCBs. And we saw an increase with age, which can be confusing if you know the literature, because little kids actually have much higher levels than adults, but we don't have adults in this study. So within the range of adults we have, we saw an increase in age. Pardon me. This is some data from a paper that was just published last month in environmental research. And this is not looking at the cohort, it's looking at the National Health and Nutrition Evaluation Survey and Haynes. And we looked at individual fish types, but this is just showing you finfish meals and shellfish meals. So the total number of finfish meals or shellfish meals reported eaten in the past 30 days. And so we looked for associations with the 8 fluorinated chemicals that they reported. And you can see that we did see significant associations, particularly with the shellfish meals, which I was kind of surprised. But they have more stronger associations with the fluorinated chemicals. So there's very little. The EPA is starting to look at these in Great Lakes fish, as I mentioned, but there's very little data on commercial fish, which is probably what this population in Haynes is eating. So we really need more data to understand what's going on. All right, so I wanted to talk about diabetes. And I think everybody's aware of the risk factors of age and ethnicity and adiposity, which is related to both foods ingested and the amount of exercise. But there's some other associations, some other pathways that are of interest in terms of diabetes etiology, including inflammation, hormones, and environmental chemicals. And the field of environmental chemicals, the influence on obesity and diabetes has really been exploding over the last decade or so. So up here I have a few just definitions that I wanted to put up here because it will help you understand what I've done in my in the slides that are coming up. So for diabetes, you can either use fasting plasma glucose or hemoglobin A1C, which is kind of a longer-term measure of glucose levels in the body. You can use those to classify people as diabetic or pre-diabetic. And if you have fasting insulin and glucose, you can calculate what's called HOMA-IR, which is a measure of insulin resistance in the body. And so the other thing that I'm going to talk about is diabetes transition. So generally, we're talking about type 2 diabetes here, not type 1, I should mention. So generally, the early stage development of diabetes is related to insulin resistance. And then later, the defects in insulin secretory ability of the pancreatic beta cells develop. So in our we're interested in understanding POPs and their association with diabetes. So this is, okay, there it is. Okay, so we use the Great Lakes Charter Boat Captains cohort to look at diabetes and POPs exposure at that 2005 examination where we measured PCBs, DDE, and PBDEs. So these are, what I'm presenting here are odds ratios for diabetes or pre-diabetes. And so these are quartiles of DDE. So you can see that the odds of having diabetes, so it's prevalent, it's all cross-sectional. The odds of having diabetes increase as the DDE level increases. And then the p-values for a trend across the quartiles. So, what do we make of this data? Well, we used hemoglobin A1C. We used that biological measurement to capture people who may not have been diagnosed with diabetes yet by a physician, because there's often a lag time after someone develops diabetes before they get diagnosed. So we saw a strong association with diagnosed diabetes. When we looked at just pre-diabetes versus normal, we really didn't see an association. So that suggests that the effect of the DDE on the development of diabetes could potentially be at later stages of diabetes development rather than at earlier stages. The other thing that's really interesting is we didn't see associations really with PCBs, total PCBs, or with the PBDEs. Although we did see some interaction, we saw that PBDEs were associated with diabetes, but only in people who were hypothyroid. And we saw a little bit of an association with dioxin-like PCBs, but not as strong as the DDE association. So we have another cohort that we've been studying too, and these are not people with specific exposures through fish consumption. They were workers at a capacitor manufacturing plant in LaSalle, Illinois. And Dr. Persky, Vicki Persky at UIC had assembled this cohort and done a morbidity study. And so I just wanted to show this to you because these, again, is a cross-sectional study, and these are odds ratios. These would be odds ratios for the for having diabetes per increase of 1 log of the PCBs. So the PCBs were continuous here. But what I wanted to show you is when you break up the PCB chemicals by whether they're estrogenic, anti-estrogenic, or dioxin-like, you kind of see an association for all of them. It's not like one of the subgroups of chemicals pops out. So this is not really helpful in telling us much about the mechanism or what might be happening. And also, we see the association. We didn't measure DDE here, but we didn't see an association with PCBs in the other study, but we do in this study, which is something that is seen across many studies in the literature. So there's almost always an association with PAPs, but it's not consistent what kind of PAPs are associated with diabetes. So that's pretty confusing, actually. So then we also looked at that HOMA-IR measurement that I mentioned that is related to insulin resistance. And we did not see any association of PCBs with insulin resistance. So that again supports maybe the effect of PAPs at a later stage of diabetes development. These were both cross-sectional studies that I've shown you. And frankly, I would say a majority, if not like 85 to 90% of the literature in this area is focused on cross-sectional studies. So with these chemicals that have a long half-life, it does make sense that if you measure current exposure, it does reflect past exposure. But there's a lot of individual variation in metabolism. And so the thought is, what if diabetes just affects how people metabolize PAPs? Maybe that's what we're seeing in all these studies. And so it's really what we call reverse causality. So it's important to have a different study design, really, to look at that question. So what we did was use the Great Lakes Charter Boat Captain study, but we used it as a diabetes incidence study. So we used the fact that it's a longitudinal cohort. So we went back to the first baseline data in 1994. We threw everyone out of the data set who already had diabetes at that point. And then we followed up people in the data until they developed diabetes, or they dropped out of the study, or they finished at the end point. And so from this kind of data, we can get an incidence density rate. So this is the results of that study. Again, we saw an association with, actually a very strong association with DDE, and not really with PCBs. We were able to identify 36 new cases of incident diabetes after the original measurement of PAPs, and we had about 4,000 years of participant follow-up. So this was one of the first studies that was published that showed that there was an association of PAPs with incident diabetes, not a cross-sectional association. And I don't have a slide on it, but since I have repeated PAPs measures in a subgroup of the participants, I was able to look at the proportional decrease per year in people who did have diabetes and didn't have diabetes to see if there might be some effect on metabolism rate, and did not see anything. So that also supports that there really might be something going on here. So I wanted to, so this is just kind of a summary of what I've told you. Just I was worried I would get everyone lost with all my epidemiology. So we have a lot of data that PAPs are associated with type 2 diabetes, but we don't have enough data still to really say they cause type 2 diabetes. And we really want to understand why that is and what the mechanism might be if it's a causal relationship. As I mentioned, no one PAP is like jumped out at everyone as the, you know, the smoking gun in this case. So, so we're still in the field measuring a lot of different PAPs so that we can maybe figure out what is the pathway. And the mechanism of action doesn't really help us. What we know about toxicology doesn't help us untangle this. And there's also statistical issues with this kind of data because PAPs are really correlated. When I measure one PCB if I measure 2 PCBs in humans and look at the correlation, it's likely to be like 0.7, 0.8. So they're very strongly correlated. So that is an issue if you want to model multiple exposures at the same time. And our studies suggest that there might be differences in stage of diagnosis. The effect might be stronger in the later stages. How am I doing on time? Okay. Okay, good. So I'm going to go through this fairly quickly. So we wanted to look at some potential mechanisms using the Chartable-Captain study because we had some leftover serum. So, so I wanted to look at adiposity and inflammation and oxidative stress and the endogenous hormones, but I'm not going to talk about the hormone data today. So the dyslipidemia is a risk factor for diabetes. It's a potential pathway, but it's really tangled up in the measurement of POPs because they're lipophilic, and so serum levels can affect laboratory values, and so we normally adjust for serum lipid levels when we do epidemiology modeling. So it's hard to understand that, so we're not focusing on that one right now. So we measured some biomarkers, and we wanted to know if they mediated the association of POPs with diabetes or if they modified the association. So I think everyone, just to be clear what I mean by that, so mediator would be a factor that's in the causal pathway between exposure and disease. And a modifier would be a factor where the effect of exposure on disease differs by levels of the modifier. And this is actually really important in environmental epidemiology because it can help us identify high-risk groups and possibly factors that can be targeted for developing interventions. So I measured C-reactive protein, which is a marker of systemic inflammation, adiponectin, which is produced in adipocytes or fat cells, and it has anti-inflammatory properties, but what's important here is it's positively correlated with insulin sensitivity. So people who have higher levels of adiponectin tend to be more insulin sensitive, which is good to be insulin sensitive. And GGT, which is a liver enzyme, and it's induced by oxidative stress. It's a pretty easy clinical marker to measure. So they had to be things that were fairly stable because we had serum that was already 5 or 6 years old. So what we didn't see was any association of the biomarkers with the POPs, which was kind of surprising because there'd been some hints in other studies that POPs might be associated with these biomarkers, but we didn't see an association. So it's not possible that the effect of the POPs on diabetes is mediated by these biomarkers. But what we did see was modification. So people who had higher BMI or higher inflammation or higher oxidative stress, the association of DDE with, in this case, hemoglobin A1C was much stronger. And the association, we saw the opposite for adiponectin because, remember, at higher levels of adiponectin is less risk. So the people that had the lowest adiponectin, who had the most risk, also had a stronger association of DDE with POPs. So okay, so this is just a summary. So I didn't find mediation, but I found modification. And it's pretty interesting because we have a colleague at UIC, his name is Rob Sargis, and he's doing both in vitro and toxicology of different environmental chemicals and obesity and diabetes. And he is also finding in animals, and others are finding, that things like diet can very much modify the effect of environmental chemicals on these endpoints. So things like putting animals on a high-fat diet versus a regular diet will potentiate the effect of the chemicals. So it's consistent with the animal studies. I wanted to point, this is kind of an interesting concept. So it's really important to us to characterize fish consumption as well as these exposures. I mentioned that you can't just characterize the exposure by fish consumption because the correlation's not strong enough. But we know there's protective factors in fish. So what this is showing is, along the bottom here, this is increasing number of Great Lakes sport-caught fish meals in the past year. And this is increasing DDE. So these people here that have the lowest levels of hemoglobin A1C, so they're got more normal level hemoglobin A1C, have the highest fish consumption and the lowest DDE. And the people that have the highest levels have high DDE and low fish consumption. So it's important to measure and account for factors that elevate risk and factors that are beneficial. And if you don't account for both of them, what happens is you underestimate your true risk. So this is from an interesting paper that was focused on mercury and omega-3 fatty acids. And so there's a lot of literature in that field that supports that you need to really adjust for risk and benefits to get proper estimates of risk. So just real quickly, we have a NIEHS study funded in the Hispanic Community Health study of Latinos. And we're following up on some of these things that I just told you about, on whether POPs are related to early development of diabetes, and if there are mediation or modification by hormones or inflammatory pathways. But we have, this is a really large cohort, and so we're going to have a really large sample size. So we're going to be able to really look at different strata. And we're also going to be able to measure insulin resistance and beta cell dysfunction, as well as the development of diabetes and prediabetes. So we've split the cohort into half are normal at baseline, and the other half have prediabetes. And so we'll look at the effect of POPs on on those two transitions. And it's I believe we'll be getting them at about 6 to 7 years of follow-up. So the POPs will be measured at baseline, and then at 6 or 7 years, all their parameters will be remeasured, and then we'll evaluate what happened based on their POP status at baseline. There's just so many people that worked on this study, but the two people I wanted to point out are Dr. Victoria Persky at UIC and Henry Anderson at Wisconsin Department of Public Health, who have been longstanding collaborators of mine. So in the little time that's left, I wanted to tell you about another study that we've got going on that also deals with fish consumption. But it's a very different study. It's got a different flavor. It's not an etiologic study per se. It's a translational research study. And it's funded by NIEHS, and they have a program called Research to Action. So they want investigators to go out, work with communities that have environmental health issues, do assessments, and develop interventions. And we decided, working with Susan Buchanan, who's an environmental health physician, and she's very interested in mercury and counseling women who are reproductive age about fish consumption and mercury contamination. And so So we decided, she had an interesting intervention idea, so we decided to work with the Asian community in Chicago. And the reason we chose the Asian community is because they have relatively higher fish consumption than the rest of the U.S. Racial ethnic populations. And we can see that in NHANES, a substantially larger portion. I think it's, I'm trying to remember, I should put that slide in. Non-Asian women of reproductive age have something like 1 to 2% have elevated mercury, and along the level of 20 or more % of Asian women have elevated mercury. So it's quite a bit different. So we're working with Chinese, Korean, and Vietnamese associations in Chicago. Pardon me. And our two objectives are to characterize exposure to mercury and PCBs in Chicago Asian populations and to develop public health messages. So we're in the assessment phase right now. We're actually have enrolled most of our participants. So our assessment is doing biomonitoring in here for mercury levels. We're not measuring PCBs because we didn't want to, well, number one, we didn't want to collect blood in the field. We have community workers, and so, you know, it's just not very feasible in this part of the study. And here is pretty easy to collect. And then there's a very detailed fish consumption survey that, and this is an actual client at in the Chinese community organization. And we're really interested in, you know, what kinds of fish they eat, what parts do they eat, how do they prepare it. We're asking a lot of detailed questions because based on our focus groups at the beginning of the study, there were a variety of ways people were consuming fish. And then what we're going to do with the data that we collect from the survey is try and estimate the intake of PCBs and mercury and omega-3 fatty acids for the different populations. And so we can get a lot of data on mercury in fish from the literature and omega-3 fatty acids from the USDA database. PCBs, not that much data on commercial fish. And so what we decided to do is to actually collect fish and test it from the markets that people are shopping from. And also we're testing different preparations they might be eating. A lot of them are eating whole fish for different species. A lot of them are eating the fillets with skin, which is generally not how they're tested for fish consumption advisories. And so we're doing PCB tests and mercury tests in different labs at UIC, and we're banking leftover fish tissue so that we can measure other things in them eventually. So this is from about a month ago. We recruited, just to give you an idea, we recruited 125 Chinese. Now we've finished the Korean population. We're still about there for the Vietnamese. By design, we have mostly females. You can see they're relatively low income, and almost all of them were born outside of the U.S. And the amount of fish they eat is actually quite large. And in fact, the Koreans are reporting eating the largest amount of fish. 66% of them report eating fish 3 or more times a week, which is much, much higher than the U.S. average. And then what I thought might be of interest to you is locally caught fish, which is varying a lot from population to population. So the Koreans are really not eating any locally caught fish. And the other groups are eating some. And for the most part, they don't seem to know where they're coming from. They're getting them from a friend, and they don't know what lake they came from. They don't know anything about contaminants in sport fish. So this is certainly an area that we can do some intervention on. And then this is my last slide. I think I'm almost out of time. So the intervention that we have planned and we're working on right now is going to be targeted to women of reproductive age who are frequent fish consumers, who are Asian. And they're going to receive text messages weekly to promote healthy fish consumption. And we're going to give them a survey at the beginning when they're enrolled so that we know what risky fish and what beneficial fish they might be eating so that we can tailor the messages to the specific types of fish that they're eating. We're going to collect hair samples again at the beginning and at 6 months when the study ends, and then we're also going to, so we'll look for changes in mercury in hair, and we're also going to look at changes in fish consumption. So it's it'll be pretty exciting. We have an investigator at UIC who's developed this text messaging system, and we're already starting to play with some messages and send them out to people just to get used to the system. So that's all I have. Thank you so much for your attention.
So thank you very much. We'll take some questions from the audience here first, if there are any.
Since so many of the cohort are low income, how do you think that's going to affect their desire to switch over to different fish options? I mean, if you're getting free fish from a friend, it's free regardless of the mercury in it. And you know, if maybe some of the lower mercury levels are more expensive, then that might be a problem.
Yeah, I mean, that's a good point. Tuna is kind of a general fish that's eaten a lot in the U.S. that can be lower in mercury but can also have moderate mercury levels. So I think we're going to explore that in focus groups with some of the questions before we go in the field, but that definitely is something that we've considered, is that one of the reasons people do buy certain kinds of fish is because it's on sale and it's cheaper. The Chinese community eats a lot of tilapia, which is relatively inexpensive. The types of fish eaten across the communities is very different. So I think it could be that we may have differences in the uptake of the interventions in different communities.
Other questions?
You mentioned that you did two surveys about to analyze the hormone, hormone levels. I'm wondering what kind of the hormone you analyze there. What do you think? What level is they will be concerned for the contamination for the hormone? What level?
So in terms of the studies that have looked at POPs and hormone levels in human populations, most of them have looked at associations with continuous associations. So they've included both people that have normal reference range and abnormal hormones. So we think that there may be perturbation of endogenous hormones, but in most cases the exposure may not be high enough to cause frank disease like thyroid disease. There have been some studies in Slovakia where there's a lot of environmental POPs contamination, and they were able to demonstrate elevated thyroid antibodies, which is a risk factor for thyroid disease, as well as increased thyroid volume. But they have really, really high exposures.
So it sounds like exposure, because I didn't see the, you mentioned DDT, whatever, you show the slides have concentration, do you have some information, how about the detection, what detect the concentration for this hormone, the data, the results, for the results,
Oh, yeah. Oh, I don't have them here, but I can send you papers. We published a lot of papers on this. So I'd be happy to send you papers. And in terms of like toxicology, there's a vast literature on the effects of POPs on hormones in different animals.
Yeah, for my understanding, it should be the concentration in the fishing. This hormone level is low. That
the fish are low. Yeah.
You know, the hormone concentration, you know, from in the fishing should be lower. Maybe not expect the human health. Maybe, but it will affect the fishing. You know. Like
well, that's a point.
Not
yeah.
Not as you know, exposing the toxicity level maybe for the level.
Yeah.
Also, very interesting for the fishing, you know, stuff, you know, because I go fishing, you know, I catch fishing, I eat the fishing, but for my understanding, most Chinese, you know, the level, you know, the metal level is higher,
right?
Higher, rather higher, because it's a fishing, but not for the PCB. You know, I doubt about the PCB, the concentration in the high in you know, eating will accumulate in the body, but the mercury is possible. So
well, so it also may depend on these are all immigrants, so their PCB levels will also be related to what exposures they had before they immigrated too. So if they were living in a heavily contaminated area, that might affect it. We see that with looking at the national data, looking at Hispanics, and they have substantially higher levels of the persistent pesticides, and we think that's because, you know, they immigrated and they were exposed a lot in their youth. So you're absolutely right. We don't have enough human data in this study to say that much about PCBs. I think most of our public health messages are going to be driven by mercury and omega-3 fatty acids, but we felt that it's wrong to ignore these other chemicals that are in fish and just talk about mercury. So we wanted to gather some data.
One more point, but I saw that before have a publication said, you mentioned it for immigrants. They said that immigrant, I think one time I saw that a couple years ago, I saw that researcher said that immigrant people, for Chinese, their metal have a metal the level the high than we call the ABC, the American born Chinese. Because so this is why I just wondering for your study, you select maybe their background already high. The mercury, you know.
Well, but so mercury has a much lower half-life than PCBs, so you can actually hope to affect levels in an intervention. It's hard to affect PCB levels in an intervention, I think, because most of them have a 10-year or longer half-life.
Yeah, my point is maybe their background, when you invest there, their background already higher. Maybe this get higher, not take fishing from the Chicago area. Maybe
right. That's why we're measuring mercury, because we, you know, whatever they brought in their bodies when they immigrated is going to be gone, and so what they have is from their intake currently. Although they could be traveling home, and, you know, I mean, there's all kinds of things that you can't control for. Sure. Thank you for your questions.
Okay. Oh, I had one then. So we're talking about maybe body burden from immigrants coming over. So have you done studies like with children, so from 6 to 16 or something, because those people wouldn't have had body burdens, you know, if the children were born here?
Oh, that's a good point. No, that's a good. We had considered putting children into this study when we were writing the grant, but it was getting too complicated, so we felt that we wanted to focus on women of reproductive age. But there's really not that much literature on mercury effects in kids. Most of it's on in utero exposure.
But I just thought that way you could see if their exposure is
similar to the adult. You know, I would expect PCB exposures in U.S. kids now to be really low, if not starting to get undetectable, because they are decreasing, so which is good. But I still think it's important to study PCBs, and I think the methodology we're using can also be translated to other emerging persistence as we find that they're increasing in the human population.
Are there any other questions? So with that, we'll end the seminar today, and I want to encourage others on March 2nd. We have our next seminar with Dr. Mike Leidy. We'll be talking about pesticides in the environment. So thank you all for attending today.